Hi guys, let's continue solving our task, and the next task would be the following one. So this task called the number of subarrays with bounded maximum. So we are given an integer array nums and two integer left and right. So we have to return the number of contiguous non-empty subarray so that the value of the maximum array element in that subarray is in the range left and right. So let's take a look and try to understand this question. So we have an array, for example, 2, 1, 4, and 3. And we have some left that is equal to 2 and right that equal to 3. And we can check how many subarrays we do have. So we have subarray 2, 2, just 2, then 2 and 1. We cannot have 2, 1, and 4 because 4 is greater than 3. Then we can have array of 1. Can we have array of 1? That meet the requirements. Okay, and 3. Okay, and why we can have array of 1? Give an integer array nums and two integer array left and right. Return a number of contiguous, maybe contiguous. Okay, so contiguous. Put it like so. Okay. Another one, 2, 9, 2, 5, 6, and we have 2 and 8. So we have 1, 2, then we have 2, then 2, 3. So 1, 2, 3, 4, 5, 6, 7. So here it should be 3 factorial. So it would be 6, right? Plus 1. It would be 7. Why it's 3 factorial? Because we have 1, 2, 3. Then 1, 2. And this one would be 3. So we have 6, and this one is 1. So yeah, so what can we do here? We can make iteration over our array and find. So we first, so it's not ordered array, okay. So we check, we take the first element, left one, that should be greater or equal to left. Yeah. And then we are going until we find the right. And then we found the number of elements. So for example, let's say that we have 2, 9, 2, 5, 6, and 7. So here we see that it's 4. 4, right? So when we have 2, we have 4 elements. When we have 5, we have 5. Then for 5, we can have 5, 6, and 5, 6, 7. So for 5, we have 3. For 6, when we have 6, we have 2, and 7, it would be 1. So in result, it would be 4, 3, 2, and 1. 4, 3, 2, and 1. So actually, it's arithmetic progression. Okay. Okay. Mm, okay. So let's implement this. So we have int result, that would be 0. Mm, we have left and right. So first we have left index, and here we are going while nums I would be is less than left. We are doing something like this: less than left, or I is equal to nums length minus 1, or nums length, I think. Yeah. It would be enough. So here it's our I. Then we are going to create our J. J is yeah, so J should be equal to plus 1, J less than nums length, J plus plus, if J if nums J is greater than right. Yeah, if J is greater than right, in this case I should calculate my result. So how can I calculate my result? I have I and J, right? So at the beginning, my I is 0. So for example, this one is 0. And my J is 1. So I can add to my result the number of elements, J minus I, plus 1, J minus I, multiply, and divide by 2. Okay. And now, when I calculate it, I should find the next leftmost element. And yeah, so here I should do like while nums, so here my I would be equal to j plus 1, and while I is not equal to nums length, and nums I is less than left I plus plus. So yeah, here I'm trying to find the next element. But it can be a situation, for example, when I have 2, 9, 9, 2, 5, and 6, right? So here I calculate, then I take this 9, and 9 greater, so it should be left and and nums I and this, yeah, nums I is left. What is left? Left, okay. And nums I should be less than right. Okay. If I is equal to nums length, then break. Otherwise, j equal to I plus 1, else. Yeah, I think it's quite complicated here. So yeah, so here when nums j is greater than right, I calculate, and here I just increment my j. Yeah, so here I just increment my j, and if else if j is equal to nums length minus 1, Then I should calculate again my result. Yeah, and j equal to nums length minus 1, and I is less than j. In this case, I again calculate my results, and here I return my result. Let's try to dry run with this test case. So I have 2, 9, 9, 2, 9, 2, 5, 6, left 2, right 8, and let's check. So what do we do here? Here we are checking nums I is less than left, so 2 is less than left, no. So yeah, so I'm not going here. Then I start with first element and I check j is greater than right. So now 9 is greater than 8, yes. So I calculate my result. And currently my result would be j minus I, so it would be 1. Here j minus 1, it's 1 multiply to 1, so 1 plus 1, it will be 1 plus 1, 1, and divide by 2, 1. So result would be 1. Then I, in my case, would be 2. And here I check, yeah, it's not equal to length. And I check that nums I is less than left, and nums I is less than right. Yeah, so here it's false. Here is false. So I'm not going here, not going here. J would be equal to 3. And then I go here, calculate this one. So here my j is, my I is equal to 2 and j is equal to 4. So we put 2. Yeah. So this one should be like this. Run. What's the problem? Error. Expected results. What's the problem with this? I don't understand. Nums I is less than left, and I is not equal to nums length. I don't know. Looks like correct. Ah, yeah. Okay. Here. Plus 3, 4. Yeah, I think that, yeah, I spent a lot of time, so let's check. Topics, yeah, it's 2 pointers. Let's check. It's DP solution, but I'm more interested in 2-pointer solution. Yeah, it's again DP. DP. Oh, here 2-pointer. Okay. Yeah, it should be something like this. Okay, but thank you very much.